Hello, I wanted to make a short video on floating point traps in Abaqus. Debugging larger simulations requires that you run in parallel, otherwise it takes too long. And I was actually having some trouble with some underflow issues and getting nans and the stress for the UMAT. So how to debug this. So the first thing, I'll bring up my env file. So this is just overriding the compile Fortran flag. And so if you set floating point exception traps with Intel Fortran, it only works for the main program, and your UMAT is not the main program. So you can add fp all, and then you'll trap the UMAT, but the performance of Abaqus tanks really hard. Something that should take 5 minutes takes hours. So to me, that's not, even with multiple CPUs, and that's not a okay solution. So ideally, you want some sort of optimization, minimal debug information, and traceback, and you also need this flag. But the way that I'm handling floating point traps is by using IF core, which Intel provides, as a way of locally in your program setting the trap information. And the key here is that you have to set the trap information at the entrance to your UMAT. So this is my Abaqus UMAT. So you set it at the beginning, and then wherever there is a return, you have to set the original flags. Otherwise, Abaqus will crash. Okay. So when you run this with a single CPU, what you get is this nice line information. Okay, so I have floating point exception at this line in my UMAT. Okay, that's great. When you run in parallel, what you normally get is this. There's no information. So how to deal with this? The way that I've gotten around it is I'll launch my program, I'll open up my the corresponding source code and in Visual Studio, and what it gives me, it will actually trap the error even though I'm running in parallel, and I have basic line information. Not all the variables are available, but you can see, okay, my inverse is really poorly conditioned. I'm having an underflow issue at this point. It's because this is close to 0 but not 0. Okay, so now I can trap floating point errors on the fly in Abaqus with pretty good speed. And if I exit, program gives me that. And if you go up, you'll see the dump file. And the dump file is now populated because it was able to get the information before creating the dump. It's exactly what we needed to see. So technically, this should also work for some of our large compute resources. We just have to attach a debugger that's compatible